What we want to do today we want to just get to a point where we're going to work towards a point where we could solve an equation like that. Okay, that didn't look very hard, right? This is review mostly until we get near the end, and then you're going to see something changes that makes this a little different than what we've done. So what's our first step? Add 5. And what's our strategy, by the way, for solving this equation? Say it again. Isolating x. How do we know to isolate x here? Okay, but it's not just because it's an x squared. Okay, I can isolate x here because there's only a single instance of the variable. I can only point to a single x, right? That's our rule. If I want to solve a quadratic equation, I want to pick the easiest method possible. In the last sections, we've dealt with problems where we've had both x squared terms and x terms, and so we've needed to do something different. We've had to factor, right? But now we're back to actually an easier type of problem to do. Here's one where, just like with our linear equations from Unit 1, and I guess Unit 2 also, we can point to a single variable, so we can isolate it with inverse operations, right? Easy. So first step would be working our way up in reverse PEMDAS, would be add or subtract. Yeah, we're adding 5 to both sides. If we're isolating, every step should be a cancellation step, right? So after one step, we get negative 2x squared equals 18. What's next? Divide by negative 2, okay? So divide by negative 2, and I cancel. And now I get x squared equals negative 9. What's next? Square root. Okay, no big deal. I square root. What's the problem? Yeah, there's the problem, right? Okay. So we need to know how to deal with that square root of a negative number. So I think this is page 4 or 5 in your notes. So we need to introduce a new type of number called an imaginary number. So equations such as x squared plus 1 equals 0 have no real solutions. So mathematicians define the imaginary numbers to represent their solutions, right? So if I were to solve that equation, wouldn't I get x squared equals negative 1? And then when I square root both sides, I would get x equals plus or minus the square root of negative 1, right? No real solutions, but we can call that a solution. Okay, if we introduce what's called the imaginary unit I, which is defined as the square root of negative 1, we can have a solution there, right? What would our solutions be? Well, we would just get x equals plus or minus what? I. Yeah. Yeah, right? So that's what an I is. I just stands for the imaginary unit, and we get the two solutions, plus or minus I, if we solve this equation, okay? So today we're just going to limit ourselves to just talking about pure imaginary numbers. So pure imaginary numbers are always written in the form b times I, where b is what we call the imaginary unit. B is a real number that's being multiplied by I to create an imaginary number, okay? So how could we simplify some square roots of negative numbers then? Let's take something like, for example, the square root of negative 192. Okay, what could I do to simplify that? So number 6. Okay, if you follow these steps up here, what we're doing is this. We're gonna rewrite the square root of a times b as the square root of a times the square root of b, right? Okay, well, all we're going to do here is we're going to change the 192 into the negative 192 in the radicand into a -1 and a positive 192. That's our strategy whenever we're simplifying square roots with negative radicands. So first step would be to write this as the square root of 192 times -1, and then split that into separate square roots. Okay, so we would get the square root of 192 times the square root of -1. And the square root of 192 could be simplified. Okay? What does that simplify to? Is what? You mean 11 squared or 12 squared? Well, 12 squared is 144. Does that divide into 192? No. What does divide into 192? No. What's the biggest perfect square factor of 192? Well, if I cut it in half, half of 192 is what, 96? So if I work my way up from 96, what's the first one I hit that divides evenly into 192? 81 does not. 64 does. 64 times 3. Aha. Okay, so I could rewrite this as square root of 64 times square root of 3 times square root of -1. Okay, well, the square root of 64 is 8. I'm stuck with a square root of 3, and a square root of -1 becomes an I. Okay, so when you're doing these, there's kind of a shortcut you can take. Anytime I have a negative number inside a square root, I always know that that negative number inside the square root is going to give me an I, right? Outside the square root. So then all I have to do is just know that I'm going to get an I and ignore the negative now, right? I'm just going to simplify the square root of 192, but I'm going to have to multiply by I at the end. That make sense? Okay, give me 1 to 5. Does that make sense? Okay, I'm going to quickly show you a shortcut for calculating, for a technology shortcut for simplifying big radicands. If I have a square root of a big number, how can I simplify that? Well, I mean, you can use this technique. We can use couples go out, singles stay in. If you don't have access to technology, that's how you would do it if you had a really big radicand. But if you do have access to technology, there is a little bit easier way. You could go into Desmos, for example, and you're just going to define, here, I'm just going to do it. Just watch me do this here. Okay, so I think you have to do this. This would be like with graphing technology, if you had Desmos graphing. So again, I'm trying to simplify the square root of 192. Okay, whatever number it is that that is inside the radicand, I'm going to create a function in Desmos graphing that equals that number divided by x squared. Okay? And then I'm going to create a table from that. So I'm going to go up to the gear and I'm going to hit create table. Okay, now I don't need negative values of x are not useful. I can get rid of those. And 0 is not useful. So I can get rid of 0 also. But then I want to keep going with this. So if I just hit enter, it'll keep adding values of x. Now I need to keep going. Here's the rule. I need to keep going until until I get an integer in the right column that is an integrand that can't be simplified. So like for example, the square root of 12 could be simplified, couldn't it? Right? So I have to keep going until I get a number that when inside a radical would mean I could stop. Okay, so you tell me when to stop. Stop, right? Because the 3, I know that the square root of 3 can't be simplified. You could, like, an easier rule would be, just be to keep going until you get down below 2. But that's overkill, because if I did that, I would go a couple extra steps and I wouldn't need to, right? And then I'm just going to pick the lowest row that has an integer in the right value, in the right column. Okay, what do these columns represent? Well, what they represent, if you do this trick, the left column represents the outside number and the right column represents the inside number, right? So wouldn't you agree that the square root of 192 is equal to 1 times the square root of 192? It's also equal to 2 times the square root of 48, which is equal to 4 times the square root of 12, which is equal to 8 times the square root of 3, and that's as far as I can go. Everybody see that? Pretty good little trick, huh? So for 192, we probably didn't need it, but if that were like a 6-digit number that you're trying to take a square root of, this is a lot quicker than doing couples go out, singles stay in, right? If you have technology available, okay? For certain questions, okay? Right, so then really, again, all we're doing here is we're going to write the square root of negative 192 as the square root of 192 times the square root of negative 1, which is going to become an I. And then I just simplify the square root of 192 to be 8 radical 3. Okay? And here is the row that corresponds. Let's put a circle around this. This is the row that corresponds to our answer. Okay, 1 to 5? Okay, good. All right. Let's do another one. How about, oh, no, never mind. We're going to go to the next page. Now we're going to look at patterns. So if we wanted to finish this problem, if we go back to this, we got most of the way there. What would my solutions be? What's my next step? Okay, so I square rooted both sides, which canceled the squared. So I got x equals, and the square root of negative 9, the negative inside becomes an I outside. The square root of 9 is 3. What am I forgetting? Plus or minus. So I get two solutions, positive 3i and negative 3i. Okay? All right. We need to go a little further with this. We need to study some patterns of powers of I. Okay, so if we look at powers of I, well, I to the 1 is just I, right? Nothing I can do with that. What's I squared equal to? Let me go back for just a second. What's I squared equal to? If we said that I is equal to the square root of negative 1, that's the definition of I. What's I squared equal to? What is it? No, hang on here. What? If I equals the square root of negative 1, what if I square both sides? Negative 1, right? So by definition, I squared is equal to negative 1. Okay? All right, so that one we know. I squared is the square root of negative 1 quantity squared, which is negative 1. What's I cubed? Using properties of exponents, what could I find the answer is? No. What is it? No. How can I rewrite I cubed in terms? No. How could I rewrite I cubed in terms of stuff I already know? If I multiply like bases, what do I do to the exponents? Add them, right? So I cubed equals what? I know what I squared and I to the 1 are. Isn't I cubed the same as I squared times I to the 1? Everybody get that? Right? Because 2 plus 1 equals 3, right? Well, I squared is negative 1, so I end up with negative 1 times I gives me negative I, right? Okay, you see the game we're playing here? Once I know the first 2 rows, I can find any other power of I just by using that information. What's I to the 4th equal to? Well, you're right. It's negative I squared, but that's not simplified. What's negative I squared? No? Yeah, you guys are just guessing. When you're sure you have it, raise your hand. What is I to the 4th when you're pretty sure? What do you think? No? It is 1. How'd you get it?
I looked up the column thingy, and it went I positive, then -1, then negative I. So then I just assumed it'd be 1 positive.
Okay, well, you guessed right, but here's how we could do it. I to the 4th. Now, I think you were just doing I cubed times I, weren't you? Yeah, because I to the 4th is I cubed times I. So negative I times I would be negative I squared. I squared is negative 1. So I'd get negative 1, which is 1, right? But an easier way to do it would just be to do I squared squared. Because if I take a power to a power, I multiply the exponents, right? Well, I squared squared is pretty simple. That just gives me negative 1 squared, which is positive, which is positive 1, right? Okay, now the rest of them get really simple. What's I to the 5th? Let me raise a hand. What, new? Confused? Could you see how we got I to the 4th? Okay, I'm seeing people are shaking their heads. They're not seeing how I'm getting this. They're not picking up what I'm putting down here. So let's what do we got here? We always want to be able, if I have bigger powers of I want to write those in terms of powers of I that I know, right? Well, we started off just knowing the first 2. I to the 1 is just I squared is negative 1, right? So I to the 4th would just be the same thing as saying I squared, which I know, squared. You see the game here, right? Everybody get that? I cubed would just be I squared, which I know, times I. So negative 1 times I is negative I. Okay, so then what's I to the 5th? I want somebody who hasn't had a chance to contribute yet. What's I to the 5th? What could I do? Now I know all these. Now I know 4 powers of I. What could you do, Atticus? Negative I times. Okay, you're right. So you did I to the 5th equals I cubed times I squared, right? Okay. Would there be an easier one to do? I to the 4th times. It'd be 1I, wouldn't it? Right? Because look, I to the 4th is always just equal to 1, right? So I to the 5th would just be I to the 4th times I to the 1. That's 1 times I equals I. What's I to the 6th? No. Okay, which is what? What's I squared? Negative 1, right? Yeah, I to the 6th, isn't that just I to the 4th times I squared? I to the 4th is 1, right? I to the 4th times I squared is just 1 times I squared. What's I to the 3rd, everybody? Negative I, because it's going to be I to the 4th times I cubed, which is 1 times I cubed. So it's the same thing as I cubed. What's I to the 8th? It's going to be 1 because it's I to the 4th squared, right? Okay, so it's 1 squared, which is 1. That works. So we can see that powers of I, integer powers of I, always cycle in groups of 4. Okay, we could take advantage of that, but there's an even easier way to do it. Even easier way to do it. All powers of integer powers of I are going to be, we'll limit ourselves to whole number powers of I. So we're not going to do negative powers of I or anything crazy like that. So whole number powers of I are always going to either end up being I to an odd power or I to an even power, right? How do we deal? What's the easiest way to deal with I to an even power? Well, an even power means it's a number that's divisible by 2, right? So we could always break these up into powers of I squared. I to the 62 I could write as I squared to the 31st. What's I squared equal to? -1. Okay, so what's this become then? An even power of I is always going to be some power of -1. -1 to an odd power is equal to what? -1, right? -1 to an odd power is -1. What's -1 to an even power? 1. So I'm always going to get, if I have an even power of I, it's always either going to be 1 or -1. We have to determine which one. So in this case, I'm going to get -1 to an odd power is -1. Okay. What if I have I to an odd power? Well, then all I'm going to do is I'm going to write that as the next I to the next lowest even power times I to the 1. So I've got this extra I at the end that we're going to multiply either 1 or -1 by. So I to an odd power will always either be I or -I. See the trick? So I to the 14th, how am I going to write I to the 14th? That's an even power of I. What's it going to be, Katie? It's an even power, so it's divisible by 2, right? So it's I squared to I to the 14th is I squared to what power? The 7th, right? So it's I squared to the 7th times an extra I. I squared to the 7th, I squared is -1, right? So that means -1 to an odd power times I. Well, what's -1 to an odd power? -1. So I'm just getting -I. See how that works? Okay, want to try a couple? Yeah, probably, right? So let's try a couple of these here. Try I. You guys want to go to board and try this? Okay, let's do I to the 100. Yeah. Yep.
I squared is
-1. Yeah, I squared. When you guys see, and you'll get real good at this because we're gonna do this all the time. I squared, you always just convert to -1. Yes. Yep. Okay, but if I have -1, is 50 odd or even? Even, right? That's it. Yep. Okay, so everybody, this one real quick. So this one, it's an even power, so these are easy. It just becomes I squared to the 50, which is -1, to an even power, which is 1, right? Okay, try another one. How about this one? Let's do I to the 213.
Oh my goodness.
Wait, shut up. 3, 6, right? No, it's fine.
Oh wait, Dad. I'm gonna go back to my paper. And that's one thing I can. Wait, you're right. Okay. I'm gonna grab this.
Good.
Third.
I swear to God, I wait, no. Yeah. Wait, David, if you flip it and give it an amount of positive.
Okay, but no, you got it backwards. You got it backwards. We always want to write it as a power of I squared. So it should be I squared to the 106. There you go. That's it. Yep. You forgot the extra I on the end. Right?
Giving them a problem.
You'd get, okay, that's not quite right. You're going to get I to the 213th. See, this is right. I to the 213th equals I to the 212th times I. 212 is 106 times 2. So you'd write that as I squared to the 106 negative 1 to the 106 times an extra I on the end, right? Times I. No, times I. Because you got that extra I there, right? Okay. So that's, go ahead, keep going. So that's negative 1 to an even power, right? Times I.
But if it's an odd, if you're squaring odd, then it's going to be negative.
Is that right?
No.
No? But the I on the outside.
How'd you get 71? 213 is 212 plus 1, right?
Yeah.
Good. That's it. That's correct. Yeah. No. No.
I'm confused.
Okay, everybody take a look. So it looks like on this one we're having just a little trouble, right? That's all right. Take a look. So what do we do here? If we have an odd power of I, we're going to break it up into the next smallest even power of I. So I to the 212 times I to the 1. Okay? So what have I got here? This is just an even power of I times I, right? I to the 212. How do we deal with even powers of I? Well, I'm going to rewrite that as I squared to what power? What's 212 divided by 2? 106, right? So I to the 212 is just going to equal I squared to the 106, right? Times my extra I. Okay? I squared is negative 1. So I get negative 1 to an even power times I. What's negative 1 to an even power? 1. So I get 1 times I equals I. Good? Okay. Make sense? Okay, one more. Okay. Actually, let's do 173. Yeah. Okay, good. Okay, keep going. Yep.
I made the 2 way.
Yeah.
Negative 1.
Yeah.
That's
That's
also
good.
what I need.
Yep. That's good.
Yay.
Yep.
Yep.
Okay, keep going. You're on the right track. Okay, good. Good.
Here, have a tissue for your teeth.
Shut up! Take that tissue for your issue.
Good. Okay. What'd you get, Katie? Yep. Okay, keep going. You're right. Keep going. So what's that going to be? All right, there you go. Yep. Okay, good. All right. Hey, looks good. Looks good. Did you guys get it? What'd you get? All right, that's it. Have a seat. Good.
Wait, I have a question. So anytime the power is on, it's just going to be I. And anytime it's even, it's just going to be 1.
Yeah. Okay, let's go through just a couple others together. Okay, let's try this one together, right? So number 17 on your notes. What would we do here if I want to simplify this? Okay, raise hands. I want to see. Get an idea? Yes, Gideon.
Would you just multiply them to 10i cubed? Or would you
No,
add them because
I can't do that because what's being cubed here in this first one? The 2 and the I, right? Okay, we have a property of exponents here that we have to be careful about. Remember, if I have a times b to the m, what's that equal to?
a to the m
AM
b to the m.
plus B times B.
Right? See what I'm saying? Okay. So then what is 2i cubed simplify to? What's that become? Okay, 2 cubed times I cubed. What's 2 cubed? 8. Right? So this part right here is going to become 8i cubed times this part, which is 5i. Okay. Now, the easiest way to do this, in my opinion, would then be just to commute that product. I can commute the order in which I multiply products. I can switch their order, right? So what would be a more convenient order to multiply those 4 things in? Because I'm multiplying 8 times I cubed times 5 times I. 8 times 5 times I cubed times I. Well, 8 times 5 is 40. I cubed times I is I to the 4th. And what's I to the 4th? 1, right? It's I squared squared. Negative 1 squared, which is 1, right? So this is just equal to 40. Okay, right? Okay, what about, I got another one for you. And this might be the last one. We'll see. Okay, what about one like that? What could I do? Okay, so I'm going to do this one the right way and the wrong way. Okay, so the right way is I have to simplify each one of those square roots individually, right? So I'd have to turn this one into what? If I take this will be our blue one. That's going to become square root of 18 times I, right? Okay. How about this one? Okay. So then I want to commute those, right? I want to multiply the square roots times I squared. Okay, so that's going to give me square root of 18 times square root of 10 times I squared. Well, I got to simplify the square root of 18 times the square root of 10. So what could I do there? Square root of 18 becomes what? 3 squared of 2 times I squared becomes what? Okay. And then square root of 2 times square root of 10 becomes square root of 20, right? And I got a negative out front. Let's make that negative. Okay. What's the square root of 20? That simplifies to 2 square root of 5, right? Square root of 4 times square root of 5. So I'm going to get negative 3 times 2 times square root of 5. So my final answer is just negative 6 radical 5. Okay? Now we have another property of exponents that we've used in the past, right? We've said the square root of a times the square root of b equals the square root of a times b. And we did that, for example, like what if I were doing, what if I did the square root of 18 times the square root of 2? How could I rewrite that? Square root of 36, which is equal to 6, right? Or if I took the long root there, I could have turned this one into 3 times the square root of 2 times the square root of 2, and that would have become a 2. And then I would have gotten 3 times 2 equals 6. Either way, okay? But look what happens down here if I try to do that trick. Right? If I try to write this as the square root of the product, I get the square root of negative 18 times negative 10 is the square root of positive 180, right? That's 36 times 5, right? So that becomes 6 radical 5. That's not our answer. Our answer is negative 6 radical 5. So this was correct. This was incorrect. What's the moral of this story here? No, shortcuts are good, but this is a shortcut that doesn't work here. How come this shortcut didn't work here? Because the negatives were there, right? You can only do this. We need like a big asterisk here that says only if A is positive and B is positive can we do that. Anytime I'm trying to simplify a product of square roots with negative radicands, I always have to simplify them individually first, and then I can deal with simplifying the square root of positive radicands. Okay, that's a really common mistake people make, right? You can't, and what would I have to do with this guy? This is where we'll end. We won't do this problem, but you just tell me how I could do this. What about number 20? What would I have to do? I'd have to simplify each of those, bring an I out of each one of those first, and then multiply them together and simplify the square root of the positive. Simplify the product of square roots with positive radicands, right? But first you have to rewrite them with I's, okay? 1 to 5, how we doing? Okay, good, all right.